Okay, so I'm going to do a semi-quick video here, real quick. Then I have to go to FedEx, then I have to get to work. Also have to ship hardbox orders. I have like 15 of them coming over the weekend. They're all packed and everything. So, this is the story about the Aerocom 1330. Okay? This whole thing has been I don't even know how to describe it. It's like blood, sweat, tears, lots of aggravation over the years. But definitely a learning experience. It kind of shaped me into what I am today with a lot of what I do. So I'm going to give you a rundown on it. I obtained 2 of these at the age of 19. So that's over 24 years ago. I had started messing around with tube amps, SB220s, and some other stuff when I was about 16, 17. Small stuff, and then I jumped right into this. So I have a friend that found 2 on eBay that were purchased at some government auction thing. And he decided he didn't want one anymore, so I ended up getting both. And this was way over my head. I didn't know anything about tetrodes and stuff, so there was a guy I met, I think I was around 18, and he agreed to help me if I gave him the second one. So he agreed, just to make it clear, he agreed to make it do 10 kilowatts peak. And I don't use this amp. I'm not going to use this amp. It's only been used in a demo load, and it's up for sale. I'm gonna go over that in the end. But anyway, so it originally had a 4cx10 in it, and I decided I wanted to put a 4cx15 in it because back then they were like super cheap. But whether it kept the 4cx10 or went to the 4cx15, it still had a lot of problems that weren't addressed. Basically got it to work and then out the door, and it was there for about 2 years. So this thing originally was on 3-phase. I'm just going to talk about all the things I've changed. With the help of others, like Peter Dahl, who since passed away. He's a great guy. Was a great guy. Rich Measures also passed away. Great guy. Reed Brandon gave some advice. I have a ex-Rockwell engineer that gave some advice. Jim Thompson, V7RF, gave some advice. And there's another guy recently that gave some advice. I forget his name, but he builds a lot. He's a really cool guy, and if he's watching this, thank you very much. I forget your name. He's built a lot of plate modulated AM transmitters. Really smart, sharp guy. So first off, a lot of what you're seeing here wasn't here. It had the 10 in it, so the screen supply, the grid supplies had a lot less voltage. The screen grid supply had half the voltage, less current capacity for the transformer for that supply. So I swapped both those transformers out. The rectifiers, everything associated with it had to be changed. I mean, there's so much. I'm like trying to, do it in a, order that can be understood. So took care of that. Protection circuit didn't work properly, would always trip prematurely, and the way this amplifier was set up after he helped me with it, the way he put it in a cutoff, the plate and screen would turn on and off. So every single time you key it, both those supplies would get energized. Okay? And the stock setup, the stock 3-phase supply, so you had 3 transformers, and they're wired in a 3-phase configuration. So we were able to use 3 in parallel, and just with one full wave doubler rectifier. Problem was the secondary voltage was only 2,500 volts AC, so he ended up stuffing the roughly 248, 250 volts line AC into the 210 volt tap to get the secondary up higher. And over time, one of the transformers shorted because you're saturating the core by doing that. So ended up with a secondary to core short. So killed the transformer. So that was a big problem there. So big mess. So now it has a full wave bridge rectifier. You see the the assembly. That's a Peter Dahl assembly. I believe Pete made that. Really cool looking. I have like four more of them. That just nice. I mean, I could just made a board or whatever, but I already had that. And it's a broadcast quality commercially made. You know. So anyway, so now the plate stays on all the time. Control grid voltage has two settings. It gets jacked up, goes up high to put the tube in the cutoff, and then I can set where the static plate current is, you know, or I can set the static plate current by adjusting that voltage with a knob on the front. Screen supply was ultra saggy because with the stock setup after he helped, the transformer wasn't rated for enough current. It was at half voltage, so it would fluctuate a lot. It also had 15 ohm resistors, two of them, one per leg, in series with the primary. It was like a makeshift soft start. Again, they were pulling a lot less current, so I guess they could get away with it. So that was ripped out. The screen and plate primaries are in parallel with each other, so they both get soft started when it's first turned on. The transformer was wound by Peter Dahl, the screen grade transformer, for a little over 2,000 volts, so I could use a resonant choke setup. I have the proper resonating caps and loading resistors, and that's a transformer. You can see it's real beefy. So I'll show you that choke in a second. There's the bias, the control grid, you know, bias transformer over there. So those issues were taken care of. Now the screen supply is rock solid. So is the control grid, you know, bias supply. Okay, so another issue, the blower was way too small. It probably was the size that would it wasn't even large. It was the original one that had been put in when it was at a shop. It probably just large enough for a 4cx15000. So that was ripped out. Problem is, I didn't know back then that you don't just go by the CFM rating, you have to also go by the pressure rating, you know, for the spec sheet. Because once you put any sort of back pressure on the centrifugal blower output, the CFM rating starts dropping, you know. So this actually has 3 KBB 63 high pressure blowers made by Cooltronics, and Jim did the calculations with around 90 degrees Fahrenheit intake temp, you know, ambient temp in the room. The tube's 15 kilowatt anode dissipation is met. So there's a thermal switch that I added below the tube socket, so it'll open everything up if that temp were to be reached. The other two blowers are in the back, so they all blow into that socket plenum. The reason why I use 3, the next size up is huge, and I would still need 2 of them, and you know, I'd get over 15 kilowatts anode dissipation. But these blowers are like $1,000 each now, and I had gotten like 8 of them for like $30 each or something, you know. So it's like, you know, why not, right? So because I use 3 blowers, I actually have a photohelic, magnahelic photohelic pressure protection gauge switch thingy. So if one blower quit and the air would start pushing out of the dead blower, pressure would drop, this will shut the whole PA down. I have each blower fused with its own fuse, and then there's a master fuse. If I just went by one, you know, they're all the primary leads for each one, you know, for the motor, they're all in parallel and they're connected to one fuse. If I just used that one fuse, and if the blower had a problem, it'd be overfused and there could be a fire. So that's why each one has its own fuse, and then there's a main fuse. So I also had to change the capacitor for the screen grid supply. The PA didn't have a stock soft start. I don't know if that is something. I don't really know much about 3-phase, so I don't know if that had something to do with it being 3-phase. You know, it had about, I think it was like 5,000 volts or so DC. But so soft start was added, and the wrong resistor value was put in. It had a 50 ohm resistor for the soft start, and it's not a timed soft start. It's like the same type of soft start I have in my 6 meter 4cx15000 PA, and it's also that type of soft starts listed on WHAI site, the really slick way to do it. And there's a fuse in series with the resistor. So that's actually the resistor. It's like stupid overkill. It's a Dale one. I had a friend that had one, so he gave it to me. So that's that works seamless. So yeah, these caps don't go to it. I use oil caps, but they're huge. I mean, they're huge. People make comments that don't really know how to do calculations. Electrolytic caps, if you stay within the ripple current rating, they'll last and don't overheat them, and keep them cool and all that. They'll last for 30, 40 plus years. So unfortunately, those caps are huge. That's why I didn't use them in the other amplifier. The 160 through 15. Okay, so the bleeder resistors were the wrong value, since it originally had 5,500 or so volts on the plate. And he jacked it up to about, it was like 80. It was like 8,000 something, no load, 8,500 or something, because he stuffed the higher line voltage on the 210 tap. Now the bleeders were overheating. They were just overloaded, and the play voltage meter it doesn't have a dropping resistor. It goes by current, so it's in series with the bleeders, and it was pinning. It used to read 7.5 kV. So now it has the proper bleeders, and the meter scaled properly, 0 to 10 kV, and all the resistors are isolated from that metal plate, and the metal plate's isolated from the chassis. And I have them running at about half of their total wattage rating. I always like to have overkill, some headroom. Okay, so another problem that I guess we both missed when we first did it was it had a 15 ohm 25 watt resistor between the B negative and ground, and when it had a fault on the plate supply at one point in the RF compartment, it blew that resistor open and ended up with B positive on the B negative, the full potential of the B positive and the B negative rail, and it blew the crap out of the protection circuit. All sorts of components blew up, and the plate voltage meter bezel popped off, and it was arcing, and that's why it's all singed there. So yeah, that was a big no-no. Didn't have any serious glitch resistors, so I put 4 200 ohm 375 watt 18-inch long resistors in there. They're all in parallel, so I have 50 ohms. Didn't have a high voltage fuse. I have a high voltage fuse on the, just drop some, on the B positive, and also one in series with one leg of the plate transformer secondary. Okay, so this, like I said, originally I had the 4cx10, went to the 15. It I don't know if I said it before, but the amp was designed to do 5 kilowatts PP. So, trying to remember everything. That's going back a long time. So, so bear with me, please. So it had, since it had the other tubes, the inter-electrode capacitance is way different on the 10 versus the 15, and it had a pi-type network with fixed caps on one side, tube capacitance on the other side, with a variable inductor. It had I think it had like a slug tune coil to alter the inductance before. Now it has a, well, it's all out now. It had like a little tiny variable inductor added by, the person when we were doing it over 24 years ago. So, problem with that is this thing had actually I'm going to show you. Let me just show you. Let me cover this up for a sec. Okay, so as you can see, here's the grid loading resistor. Actually, that's not the right value. I don't know why it says 10. It's actually a 5K. This must be, they had two different tube versions. This must be, let me see, hold on. They changed the tube at some point, so just a double check here. Here's another one. I pulled this out of the book because it was complete. So yeah, so 5K. I had a 5K resistor for the grid loading resistor. You can see, yeah, it also didn't have the parasitic suppressors for the grid, or either grid, you know, the screen grid or the control grid, which created problems. So, see, these were the inductors, and you replaced these with a different one. You had the fixed cap over here, you had the driver here, and the other side of the pie was the tube capacitance. So yeah, it was just very, very unstable, and when it originally came back, it was like well over a 3-to-1 SWR, and as it was keyed, the input SWR would rise because it was unstable. It was not correct. So let me go back over here. So I ended up taking out that fixed cap, put a variable cap in there, got the SWR down. That was like years ago, and it was still very unstable. So it wasn't up until like 3 years ago or so that I got the proper info from the gentleman I was telling you about that builds the the plate modulated transmitters for the AM guys, and now it has a 1 to 9 unan with the proper grid loading resistor, still has a Bruins bridge circuit, basically same setup as that guy overseas that makes the Tetra stuff. But huge difference. There's a little bit more to it, but so yeah, before when it left the guy's place with that fixed cap, it literally took a kilowatt in PP to get the 10 kilowatt PP out, which is just crazy. Now it's like 100 in, it's over 10 out, so, but yeah, this thing's just dumb. I know, and it's not going to be used, so it'll go away someday. If not, it'll, my next of kin will take care of it. Okay, so it had a Peter Dahl filament transformer that I had made, and I took that out, and it had a humbucking circuit, disabled that. I did that after the fact, and it has a regulated DC supply to light the filament, so the filament voltage is rock solid. And then I learned after the fact that the cathode emission life will be shortened by using DC, but I don't really care, because how often would you use something like this? And a normal tube lasts for 15,000 hours anyway, so anyway, so that's that. So a lot of wiring had to be changed. A lot of gauge wires were not the right size after it left there, and then when I it was made to work, just obviously not right. Now it's continuous duty. Everything I like to make, everything I make, I like it to be broadcast spec CCS 100% duty cycle. So yeah, it's just the way I do it. So let me show you that choke real quick. See, you see the choke. You can't get back there, there's not enough room. There's the choke, you got the resonating caps, the loading resistors. There's the Peter Dahl screen grid transformer. Now it has diodes between the B negative and chassis, so in that 15 ohm here, and it goes over there. But you see the protection board, that's all correct. So yeah, protection works properly now. Plate current overload, screen current overload. No longer does the tripping thing where it would cycle like super fast. It would cycle, and while that's happening, the plate and screen supply on off like rapidly. Now it'll cycle, and it just unkeys it. It opens the key line. It doesn't cycle the supplies, and and then after like, I don't think it's like 5 times or so, it just shuts down. Everything shuts down. Plate, everything. Blowers continue to run. There's a delay off timer, which isn't even needed. I found that out after the fact. Actually, my Rockwell buddy said, if you have the right size blower, the tube will never exceed its temp spec, and once you know, if it's keeping it cool, once you shut it down, the tube's not going to start producing more heat, so it's really just not needed, but it's already there, so I left it. The rectifier assembly has 2 fans behind it. The back of the RF deck cover has fans pulling air out. So the protection also has a switch where I could flip it, and then if you hit the overload point, it'll one of those, you know, for the screen or plate overload, it just trips right away and shuts down. So there was a lot of work, a lot of live and learn. You know, I think like 13 years ago I made another one in a much smaller cabinet, and I regret it. I mean, I took a lot of what I learned, and then some of what came out, what was in this also went in it, primarily like the protection circuit and then the input circuit setup with that grid loading resistor. And there were, you know, the screen supply really isn't big enough, and I mean there's some, well, there was enough room. I mean, it was like a replacement doll made by, you know, when Jeff had it, and it just the transformer didn't have the same regulation as you know, it wasn't as stiff as the PEAT. You know, I didn't find that out till after the fact, so I couldn't go like gross overkill with it. I just went a little bit bigger. This one has gross overkill. But any of the transformers, they just didn't have the same. They weren't the same. So the secondary resistance was higher. So yeah, there was that, and everything was crammed into a small cabinet. And yeah, that thing was, it was a lot of work. It was challenge to get everything to fit in the cabinet, but also still has the setup where it has same transformers, 3 of them, and it has the same setup where the screen and the plate, or at least it did. I don't know if it still does. I don't know if the person changed it, but the plate and the screen turn on and off to turn the tube on and off. So that thing will end up having problems, but live and learn, right? I didn't sell it to the guy. I went to another guy who was happy with it, and that guy sold it. So I heard they changed the band it operates on. So anyway, that's about it. But there's something else I wanted to say. I wonder if it'll come back to me. But you know, I like amps. I like making things, and you know, you just get to the point where you grow up and you realize your biggest gain is in your antenna. I remember what I was going to say. I'll say it in a sec. But your antenna and your feed line, all that, you know, to gain 3 dB, you have to double your output. You know, to gain, you know, so technically, you know, I'm not going to run that 6000 at an illegal output level, but just say hypothetically, you know, that amp can do 12 kilowatts. This can do what? What's it supposed to do? About 30, 28, 29? So that's not even an S unit. You know, is it worth it? You know, this thing, this is what I was going to say before that I forgot. For Class AB, you need an amp of static plate current. So with 8,000 volts on the plate loaded, that's 8 kilowatts right there, just to bias the tube on. Just to bias it on. Filament pulls 1,000 watts, or here over there 1,000 watts, then you have the 3 blowers. So with it keyed on, with it keyed and biased on, with everything added up, it's like over 11 kilowatts just to key it and have it biased on. That's before you even start producing output. And then what are you going to do? Have it crank? I mean, a tube amp at best is what, 65% efficient or so with a multi-band amp. So it could change depending on what band you're on. And that's at full output. So would you have something like this cranked up all the time? You know, if you run it. Oh, anyway, so what are you going to do? I mean, that's just a crazy. It's a crazy amount of power. It's just stupid big. It's illegal and all that. So anyway, it was fun. I learned a lot, and you know, the guy taught me some, and then I wanted to know more and more and more and more. So I kept branching out, reading William Moore's books and Karen feeding a power grid tubes, all sorts of literature online. And remember, all of this was before YouTube, 24 years ago, 23, even 20 years ago. It's all before Facebook, pictures on Facebook or Google or whatever. So, I was forced to learn the hard way, and that's how you actually learn, just copying stuff, because a lot of things made are just not correct. And if you don't understand how something works, you don't really know how to make something correctly or make it better, or understand why something failed, and then alter it to make it better so it won't fail again. Changing parts really isn't the right way to do it. Just changing parts until it works, or will stop blowing up. So, but yeah, I thank all those people that have given me advice over the years, and very grateful to also the people who've since passed away. And I'm still learning. It's a lot of fun. But so that's the story of the Aerocom 1330. Also had a bunch of meters made by Ram Meter, like this one. These weren't scaled properly. This was 2 amp. That was, I forget what that went up to, I don't remember. It was a lot less than that. It's for the screen current, plate current. That one made. This one went up to 300 volts, I believe. Yep, and goes a hair over 1500. It's like a line, so that's fine. I didn't bother getting that one changed. So just so much. There's so many little things that were an issue. People don't understand how much time it takes. Just lots of time. But alright, well, I'm going to go to FedEx and also the post office, and then come back here, get to work some more. And I appreciate everybody watching. If you have any comments, please throw them down in the comment section. Again, I'm not using this. I'll never use this. It'll go to someone outside the United States, but it is neat. Oh, there's usually a plate down there, and there's a front panel. It's just, I have side panels. They're all outside, up in the top of my garage. I just never reassembled it. I didn't want mice getting into it and making nests or whatever. I don't think they'd eat. This is all Teflon wire. I don't think they'd eat Teflon wire, but you never know. The number 4 wire for the line wire, that's not Teflon, so maybe they'd eat that and make nests or whatever. Mice are little nasty creatures. They do a lot of damage. Okay, so again, thanks for watching and have a great day. Please like, share, and subscribe. 73.